Alright, so we'll look at how we can answer these trigonometric questions. So these are coming from tutorial sheet 8. There are quite a number of questions that we're going to handle, different concepts that involve trig. As you can see, these are quite a number of questions. Okay, so this is basically not actually the last questions. There are some more questions that are coming below there. Okay, so we'll get started from question 1. Now the question says express each of the following angles in degrees. So here the measure we've been given are radians. Now I want us to convert to degrees. For the second question, it's actually the opposite. They've given us the angles in radians, or sorry, in degrees, and then they want us to deal with what do I say again, in radians. So we've been given radians, they want us to take to degrees in the first question, and then the second question they've given us degrees, they want us to take them to radians. Okay, how do we handle these simple questions? So for the first one, there are two ways. 3 pi over 4. So one thing that you can understand is the fact that if I was to give you the quadrants and then I give you to say that's 0, that's 90, this is 180. You should also understand that while there's 180, it's pi. While there's 90, it's pi over 2, meaning that it's half of pi. So this very part is what we're going to be using as our conversion factor. So if you're going to be given 3 pi over 4, there are two ways you can handle it. Either by multiplying by 180 over pi. So you're putting pi on the opposite what? You're putting it on the denominator so that it can divide. Okay? So therefore the pi will divide, and then you end up with just 3 multiplied by 180 over 4. Okay? At this point you can easily divide, right? 4 into 180, that should be giving us 45. So 4 into 18 is how many times? That's 4 into 16, carry 2, that's 5, 45. 45 times 3. So 45 by 3 is what? So that's a 15, that's a 12, 13, so 135. So basically that's 135 degrees. Okay. So another faster way of instead of doing whatever we did there would be, where there's pi, just put 180. So 3 times 180 over 4. We find that we're getting up to the same, getting to the same answer, right? Now conversion back is actually the opposite. So let's work with the same 135 that I've found. 135 degrees. Or even before we get to that, let me give you another example. Let's say we've got pi over 9. So there are two ways of converting this. One would be, since pi is on top, we'll put it on the denominator on the what we're multiplying with, and then we'll put 180 on top. So you end up with just 180 remaining, divided by 9. 9 into 18 is twice, so remaining for 20 on top. Or just instead put 180 where there's a pi. Yeah, end up with the same result. You can go to 11 pi. Feel free to pause the video and try out this one, convert it to degrees. So basically that gives us 11 pi over 18 multiplied by, so a pi will be on the bottom and then 180 on top. So pi 18 here, it's 1, 18 there, it's 1. So we have 11 multiplied by 10, which is just going to be 110 degrees. Okay. 155, which we found there, should be able to give us back that. So since here we've got degrees, when multiplying we're going to put the degrees on the bottom, which is 180, and then on top we'll put the pi. Okay, find common factors between 135 and 180. Okay, so we find that 45 can be divided. 45 into 155 is 3 times, and then into 180. If you look at the quadrants, this can be divided into 45, 45, 45, 4 times. So remain with 3 pi on top over 4. That's how you get to radians. Okay, now let's do a bit of some practice. 210 degrees. How do you convert that to radians? Suppose if you don't try it out. So obviously we'll divide by degrees and then multiply by the pi. So any common factors you can think of? In case you can't think of big values, let's think of 10. 10 into 210 is 21. That's 18. 18 and 21 should have a common factor of what? 18 can be divided by 9. 18 can be divided by 3. 21 can be divided by 3 as well. 3 into 18 is 6. 3 into 21 is how many times? 7. So we have 7 pi on top over 6 radians. Okay, for practice, let's convert fate as well. Pause the video and try it out. So divide by 180, and then multiply by the pi. Now we know 30 or 3 can cancel the zeros. Now 3 there, it's 1. 3 into 18 is 6. Right? So you have pi over 6. That's it for question 1 and 2, right? You're able to deal with the others. This is very simple and straightforward. Now, question 3 is asking us to express the given angles in terms of acute angles. So we have to understand, because we can say actually in question 4 is having the word acute angle. So from my understanding, from what I know so far, an acute angle is an angle that is between 0 and 90, or in other terms, yeah, between this range, the first quadrant to be specific. That's acute. Was acute angles. So whenever they're asking you for that, all that they're just trying to do is asking you to find the angles in the first quadrant. Now there are a few things that you have to know that I have already taught in the basics to trigonometry. So ensure you're registered on our site. I've explained all the basics of what I'm talking about right now. Okay. So all students take calculus. So for those who want to watch the introduction lesson and the full topic on our website, the link is given in the description. Okay, so all students take calculus, so you have to know where each is positive. In the first quadrant, all are positive. In the second, only the sine, tan in the third, and cosine in the fourth quadrant. I know that, please. So when they give you sine 170, every time ensure that you're dealing with the x-axis. This side we've got 180, this side you have 0. Okay, and there we've got 90. So actually where there is 0, if you're after a full evolution, it becomes 360 degrees. So 170, where do you expect to find 170? 170 is less than 180, right? But in the second quadrant. So 170. Now what's the difference between the 180 and the 170? There's a difference of what? A 10. So that 10 gives you the angle in the what? In the first quadrant. So in other terms, what we're trying to say here is sine 170, which is given in the question, is basically just equal to sine 10 degrees in the first quadrant. Now what determines the sign of this is where you are. We are in the second quadrant. Sine is what? Positive, so it remains positive. You can get a calculator, you will see that basically sine 170 is equal to sine 10. Okay, so if you've got an angle that is less than 180, or in the second quadrant, for you to find the reference angle, subtract from 180. If it's after 180, like maybe say 210, but less than 270, you should ensure that you do what? That you subtract 180 from it. If we had a 210, for example, 210 minus 180 would be a 30. So that would be the reference angle 30. Yeah. So it will make sense later on as we get down there. Let's look at the next one, tan 330 or tan 300. So why is 300? Do you think it's in the fourth fade or the fourth quadrant? So 300 clearly is after 270, so it's going to be in the fourth quadrant. So when you've got an angle in the fourth quadrant, you subtract from 360. 360 minus the 300, it gives us tan what? 60. Now, what determines the sign is where you are. This quadrant only cosine is positive, so it's going to be negative tan 60. Okay, implying that tan 300 is going to give you a negative answer, negative tan of 60. Okay, that's very, very important. Now, pause the video and try out the next one, cos 200. When you say cos 200, what do you basically mean? Which quadrant are you in to start with? 200 is between 180 and 270, so meaning that we are in the fade quadrant. So subtract 180 from it. 200 minus 180 is what? It's 20. So cos 20 degrees. By the way, when you subtract by either 180 or 360, or from 360 and from 180, always, if you've done the right thing, you should get an answer which is less than 90. If you get an answer which is over 90, then it is not an acute angle, then you're wrong. Okay, so know that. So cos 200 is equal to cos 20 degrees, because we found the difference between 180 and 200, because 200 is in the third quadrant. Now what determines the sign is where we are. We are in the third quadrant, tan is positive, so all the other two are negative, so therefore it's negative cosine of 20 degrees. Okay, now we've been given some examples of negative angles. Now we understand that angles basically from the quadrants, angles are move anti-clockwise. So if we're going to move clockwise direction, in a clockwise way like this, it means it's going to be negative. So if you say you're given negative 50 degrees, that's the same as, instead of going this way, the normal way, but you go the clockwise way. By how much? 50. Now 50 will not make us go beyond, will not make us go up to 270. It's just within the fourth quadrant, right? 50. So 50, negative 50 means you go down in the fourth quadrant instead of going up as we do every time. So that's why some people at this point will just say, whenever I've got a negative, add to 360 to know where you are going to be. So 360 plus the negative 50, that will probably give you the value of 310. So that's the angle we're dealing with. So if you look at sine negative 50, that's the same as sine 310 in a clockwise way, or in the anti-clockwise way. Yeah. But for me, I would look at it in this point of view, knowing that 50 degrees means we've gone down by 50. So this 50 is within the fourth quadrant. So we're supposed to subtract from 360 again, which will still give us 310. Now 310, what angle do we have? We've got sine there, so sine 310. Now is sine positive or negative in the fourth quadrant? It's of course negative, because only cosine is positive there. All students take calculus. Cosine is positive, so sine should be negative. Okay, now don't forget that we need to find the acute what? Angle. So the angle we are making with the x-axis is 50. So if we go back in the first quadrant as well, it's going to be 50. Okay, in other terms, if you want, since you've got a 310, Find the difference between 310 and 360, which is still going to give you what? A 50. So it's going to be negative because sine is actually negative in the fourth quadrant. That's very important and key to understand. So with what I've explained, are you willing to try out cos of negative 20, cosine negative 20? Okay, pause if you don't try it out. So that just means we are going again 20 degrees in the other direction. So since it's 20 degrees below that and it's an acute angle itself, you can just bring it up on top. So cos negative 20 is the same as cosine 20. Now is it positive or negative? Since it's in the fourth quadrant, cosine is positive in the fourth quadrant. All students take calculus. Cosine is positive, so that's positive. You can try on the calculator. Cosine negative 20. Let me grab my calculator here. Cosine of negative 20 is 0.9396. Even positive, same answer. Okay, now the next one is a bit unique and a bit different from the third one, as you would see. Here we are taught to look at sine 100 cos 330. Now here they're asking to say express in terms of trigonometric ratios of acute angles. So not only are we finding acute angles, but we're going a step further and find the ratios or the actual values. Okay, now this is a part that requires you to understand the aspect of the spatial angles. Okay, by now, if you've not yet gone to the introductory video to trigonometry where I've explained the 30-60 triangle, okay, so watch that video. 30-60, 45-45, these are going to be very cardinal as we look at these questions. So I'll just give you one. I'll give you this one only. 30-60. So SOHCAHTOA tells us we know sine 30 is equal to 1 over 2, meaning that that is opposite over hypotenuse according to SOHCAHTOA. So the hypotenuse is 2, the opposite is 1. The other side will obviously be root of 3. We can generate the other angles from this triangle that involve 30 and 60, and even including 90, by the way. Okay, so sine 100. So the first step is to find the acute angle. Now sine 100, always you're advised to draw the quadrant. All students take calculus, and then if you look at that, what are we saying? Where is 100? Remember it is 0, 90, 180 or pi, and then this is 270, 360. So when you're talking about 100, where is it? Is it in the first, second? So we can say that it's in the second quadrant because it's between 90 and what? 180. So when you've got an angle in the second quadrant, to find the reference angle or the acute angle, subtract from 180. So it's going to be sine 180 minus 100. So 180 minus 100 is what? That's 80. Now, in the second quadrant, only sine is positive, so this is still positive because we have sine there in the second quadrant. Now, is there a way that you can express sine 180 in terms of addition of either 30, 45, 60, 90, or any special angles that you can think of? I couldn't think of any, so I'll just end at this point for this question, unfortunately. Yeah. If you can think of a way, please comment in the give us a comment and we'll gradually review that. Okay, now let's look at this one. Cos 330. 330 is in which quadrant? It's between 270 and 360. So that makes it, for us to find the acute angle, subtract from 360. So cos 330 gives us what? Cos 360 minus 330. That's cos theta. Now cosine is positive in the fourth quadrant, so it will remain positive. Now cosine 30, we can, using the triangle that I've drawn on the left, we can find the ratio there. According to Sokotoa, for the cosine part, it basically cosine is equal to the adjacent side to the angle 30, which is root 3, over the hypotenuse, which is a 2. So that is the ratio, positive root 3 over 2. If the acute angle was negative cosine 30, the answer was also going to be negative root 3 over 2. Now tan 500. Now whenever you see an angle that is beyond 360, just quickly, don't even waste your time, subtract 360 to understand which quadrant you're in. So 500 minus 360 is what? So to 360 we just need to add a 40 to make it 400, and then from 400 to a 500 is 100, so it's 140. So forget about the 500, we're not interested in it. What that means is we just did one full revolution and then added an extra 140, so end up falling in the second quadrant. Okay, so tan 140, since it's in the second quadrant, the 140 can be subtracted from 180. It gives us what? 40. Is tan negative or positive in the second quadrant? Only sign is positive, so this is going to be negative tan 40. Is there a way we can find tan 40 by either expressing it in terms of addition, subtraction, or 30, 45, 60? I can't think of any way right now. So we'll just end at that point. Now we can deal with some radians. We've dealt with the degrees for too long. Let's get to work with the radians. So I can just change a few things here. So that's 0, pi over 2, pi, 3 pi over 2, and 2 pi. Some of you are so conversant with degrees that you can't even, you don't want to work with radians. So if you want, since I've already taught you the conversions and maybe you already know, work with that. Convert your angles, the given angles, to degrees before you deal with them in radians. So if you look at the first one, sine 2 pi over 3, just for practice sake, what do you think would be that angle in degrees? So a good student will just put 180 where is pi, and then divide by 3, which is of course going to be 60 times 2, 120. So what you're just trying to find is sine 120. Okay, so sine 120 is in which quadrant? It's in the second quadrant. So that is in the second quadrant. 2 pi over 3, or 2 third is less than a pi, so we can subtract from pi. Okay, common denominator 3, 1 through 3, it's 3 times pi, 3 pi minus 2 pi, which is going to give us pi over 3. So we have sine equal to sine 2 pi over 3 is equal to sine, we found pi over 3. Okay. Now is sine positive or negative in the second quadrant? It's positive, so that remains positive. Now sine pi over 3. Some of you know that you put 180 where there is a pi. 180 divided by 3 is what? 60. So what we're trying to find there is sine 60. This applies. So sine 60 is obviously going to be opposite to root 3 over hypotenuse 2. Suppose if you don't try out now, combine the aspects of radians with negatives, right? What do we have for the negatives? Cosine negative pi over 6. Not conversant with degrees. Right? So work with a 2 pi there. 2 pi. And then we are going to subtract, since we're going below by that magnitude, negative 5 pi over 6. The fact that negative 5 over 6 or 5 over 6 is less than a 1. Okay? Now if you want to try this, if you want to know where we're going, and you're not so confident with radians, so just convert it to degrees quickly. Negative 5, where there's pi, we'll put 180 over 6. 6 here, it's 1, 6 there, it's into 18, it's like 3, so 30. 30 times 5 is like 150. So I have cosine of negative 150. So you can clearly see now that it gives you a clear picture when you convert to degrees. If you are confident with degrees, you would understand now that this is going to go beyond the 3 pi over 2. It's going to be 150 is going to be somewhere here, because from this is 90, so the 90 plus, for us to end up with what, a 150, would have to add what to, would have to add a 60, so it's an extra 60, okay, from the 3 pi over 2. Now the angle that we're interested in for us is this angle. And how do we find it? Since we've already moved by 60 within the third quadrant, this is 60, because here it's 90. 90 from 360, from 2 pi to 3 pi over 2 is a 90, and then a 90 we've added a 60 to make it 150, and it's negative because we are moving in the clockwise direction. So that means we're remaining with only an extra 30. Okay, it means we're remaining with a 30 between the 180 and our angle. So what becomes the reference angle? Remember, every time you're trying to deal with angles, the angles that you're interested in are the angles between the angle and 180, or after 180, and less than 360. These are the angles that are of our interest. So we can't get 60, which is made between the 270 and the angle. We were interested in finding the difference between the angle and pi. So we are saying that the difference is 30. Okay. Now 30, you know that if you convert it to radians, it's going to be pi over 6, right? Now you ask yourself a question. So that's going to be cos pi over 6. Is cosine positive or negative in the quadrant we are in? This angle fell in this quadrant where tan is positive, so it's going to be negative. Now cosine 30, looking at this triangle, tells us adjacent, so it will be negative root 3 over hypotenuse 2. Okay. So this is how you handle question 3 and 4 basically. Now, question 5, I'm not going to answer question 5 just now. I'm just going to give you a hint now to go about question 5 and 6. Given that theta is an acute angle, express it in terms of sine. So we're basically just doing whatever we've done so far. Okay? So when you see sine negative pi, now one of the key statements that you're given here is where I thought that the angle should be acute. The theta in the brackets is acute, meaning that it's less than 90. So if I give you negative theta and it's an acute angle, first of all, I said if it's negative, you have to understand that then you're going below below instead of going up. So that will be the angle that you make here. Now the fact that the angle is acute, it means it doesn't go beyond 270 because it's less than 90. And so since it's less than 270, since it's less than 90 and is within the fourth quadrant, and this is the angle it is making with the 360, that angle itself automatically becomes what? The reference angle in the first quadrant. So that becomes sine theta. Now the question is sine positive or negative in the fourth quadrant? Since this angle is in the fourth quadrant, sine is negative because only cosine is positive in the fourth quadrant. That concept applies to all the other questions, and you can actually prove this. Sine negative 30 is equal to negative sine 30. You can punch these on the calculator. They're going to give you same answer, negative 0.5. Okay. Now, to make it more interesting, let me try to attempt part 2 of question 5 so that you have your homework to try out the all of question 5 and 6 in both regions and angles, or in degrees, sorry, where necessary. So here we have sine pi over plus theta. So I told you this is 0, that is pi over 2, and then this is pi, right? Because this is 3 pi over 2. When they tell you to say you've got pi plus theta, it implies, since the theta is an acute angle, that's a difference now. That's an angle it is making with the pi over 180. So that angle is in which quadrant? It's in the third quadrant. Now we understand that only tan is positive in the third quadrant. Remember, all students take calculus, right? So the sine pi plus theta in the first quadrant, the reference angle can just be the same angle theta. So the pi that is put there is just helping us determine the quadrant that we are in, and that is the third quadrant. So that will make the answer to be negative. Okay, so it's negative sine of theta. So you can now understand 360 minus pi. It means the angle is in this quadrant. It is a few degrees less than 360. So that angle is the theta. Now that would be sine what? Sine theta. Is it positive or negative in this quadrant? It's negative. Apply the concepts to answer the others, and also question 6. This is where I'll end in this video. Okay. Now, if you want to have access to all these other questions that I had, register on our site or Patreon or YouTube Premium. You'll be able to access all these solutions. Okay, these are a lot of questions that can help you understand trig, and this will help you out.